Hello everyone, welcome to this video on learning mathematics through concepts and examples. Today we are solving mastery exercise 8 from your intro to statistics class, and the topic of this video is hypothesis testing. Let's get started. First example. More than 57% of workers got their job through college. Express the null and alternative hypothesis in symbolic form for this claim using percentage. So here, what they're saying is more than 57% of the workers got their job through college. So here, the percentage of people getting the job through college is greater than 57%. And that is the claim here. Okay, that's what is claimed here. We have to write the null and alternative hypothesis. So here, the null hypothesis denoted by h sub 0 and alternative hypothesis is denoted by h sub a. So here we have p greater than, because we have a greater than there. So this must be the alternative hypothesis, because in the null hypothesis, we have equal to sign. So we can say P is greater than 57%. That's our claim. We are asked to write with percentage. That's why we are using 57%. And the alternative hypothesis is P is equal to 57%. Because in alternative hypothesis, we use equal to sign. This is one way of writing. Sometimes we can also write little bit differently. So that is, we can also write like this. Alternatively, null and alternative hypothesis. Alternative is P is greater than 57%. This will remain the same. Okay. But in the null hypothesis, what we can do is we can write the opposite of this one. We have P greater than 57. We can write P less than or equal to 57%. So still we have that equal to sign, but we may sometimes also use the opposite of this one. So we can also write like this. So throughout this video, I'm going to use equal to sign for null hypothesis. If you need the inequality format with less than or equal to or greater than or equal to, feel free to do so. Example 2 now. Let's find out what is asked here. A commonly cited standard for one-way length or duration of a school bus ride for elementary school children is 30 minutes. So that is the average time for the bus ride, 30 minutes. Okay. So you can see we have mean equal to 30 minutes. So because we have equal to, that should be the null hypothesis. A local government office in a rural area randomly sample 100 elementary school children in their district and find the average time of 38 minutes. Now here, this is the 100 is the sample size and 38 minute is the sample mean. Okay. Find the average of one-way commute is 38 minutes. That is the average with the standard deviation of 8 minutes. So the standard deviation for this sample of 100. So the sample standard deviation is 8 minutes. We are not doing the complete hypothesis testing here, but what we are asked here is which of the following is the correct set of hypotheses for testing if the average commute time of the elementary school students in this district is different. Here is the keyword, different than, okay, commonly cited standard of 30 minutes. So when we say different from, same means equal, different means not equal. So that means in your null hypothesis, you will have mean equal to 30. Okay, in the null hypothesis, you'll have mean equal to 30. And here we can say, using this concept here, our alternative hypothesis will be mean is not equal to 30, different from 30. So if you look at all these, so we must have mu on both. So that means E is the correct option. You can see mu equal to 30 for the null hypothesis. And for the alternative hypothesis, mu not equal to 30. That means E is the correct option. Okay, E is the correct choice of mean, the null and the alternative hypothesis. Okay, let's move on to example 3. Okay. A food inspector inspects sample of food products to see if they are safe. This can be thought of as a hypothesis test with the following hypothesis. So the null hypothesis, the food is safe, and the alternative hypothesis, food is not safe. The sample suggests that the food is safe, but it is actually not safe. So what's going on here is, if you think of your null hypothesis and alternative hypothesis, okay, they say that the food is safe, but it was actually not safe. In fact, the null hypothesis was false. Null hypothesis was false and alternative hypothesis was true. Okay, the sample suggests that the food is safe. Although it was false, it is considered as safe. That means we are doing the wrong decision here. For the false, we are saying it is safe and we are taking that food. Meaning of that is the error that is made here is when the null hypothesis is false, we are supposed to reject the null hypothesis, but here we fail to reject the null hypothesis. So this must be type 2 error. Okay, that must be type 2 error. Okay, next one. Example 4. If your null and alternative hypotheses are, so here we have, this is the null hypothesis, P is equal to 0.7, and alternative hypothesis is P is less than 0.7. Then the test is, you can see because there is a less than, lesser numbers are on the left. So this must be the left-tailed test. Okay, this must be left-tailed test. So the correct answer choice is part A. Okay. Now let's go to number 5. Test the claim that the proportion of people who own cat is significantly different than 80% at 1% significance label. Okay, here in the first step, we are asked to state the null and alternative hypothesis. So your null hypothesis would be P is equal to 0.80. And in the alternative hypothesis, because we are talking about significantly different, so your alternative hypothesis will be P is not equal to 0.80. So that is the answer for part A. That is our null and the alternative hypothesis. Okay, we got the first part there, null and alternative hypothesis. Now the second one says, is this one-tail or two-tail test? Because here we have not equal to sign, so this must be the two-tail test. Okay, this must be two-tail test. Because here is not equal to sign in the alternative hypothesis, this is two-tail test. Based on the sample of 800 people, now we have the question here. Sample of, 600 people, n equal to 600, okay? 83% own cat. The proportion of people who own cat in that sample, P hat, is 0.83. 83% own cat. That means the remaining 17%, they don't have the cat. We have to find the p-value. Okay, in order to find the p-value, first, what we need to do is we need to find the test statistics. So let's find the test statistics here. Because it is the proportion, the test value will be z. So z is equal to, our formula is p hat minus p divided by square root of pq over n. So p hat is, okay, hold on, here it should be p minus p hat or p hat minus p. Either way it works, in fact, because it's a two-tail test. So I'm going to use that. So p hat is 0.83 minus p is 0.80 divided by square root of p is 0.8. That means q will be 0.2 and the sample size n is 600. So now if we simplify this, we get the test value, which will be 1.8371. Okay, that will be the test value. Test value will be 1.8371. But we're looking for p-value. Now, in order to find the p-value, we need the distribution here. We need the normal distribution. So we are going to use that normal distribution. We are going to draw the normal distribution and then find that p-value. So this is my normal distribution, standard normal distribution with mean 0 and standard deviation 1. This is a two-tail test, meaning of that is your rejection region is on both tails like this. Okay, and then the value that we got here, z value is 1.8371, which will go here, 1.8371. Now, the area on the tail, the total area on the tail is p value. So here on the left, we have half of that. So this is p over 2. And this side, we have p over 2. So the p value will be, in order to find this area, we use the normal CDF in our calculator. Okay, normal CDF in our calculator. Now for this area on the right, the lower boundary is 1.8371. Upper boundary will be infinity or E99. Mean is 0, standard deviation is 1. And if we simplify this, the p-value will be, okay, in fact, the p-value is not just that. That is the area on the right tail. We have to multiply this by 2. So once we type this in our calculator, we have to multiply the result by 2. So by doing that, we get 0.0662. 0.0662. Okay, so that is the p-value. So that is the result for part C. In part C, we are asked to find the p-value. We got the p-value there. Now, the next part, part D. In part D, based on the result, we need to reject the null hypothesis or fail to reject the null hypothesis. So for that, we compare the p-value with the significance label. So here, what we have is our p is 0.0662 and the significance label is 10%. Okay, so you can clearly see that the p is less. P is less than alpha. And when p is less than alpha, we reject null hypothesis. We reject null hypothesis. We reject null hypothesis. So the answer for part D, whether we reject or fail to reject, we in fact reject the null hypothesis. So that is the answer for part D. So this is the complete hypothesis testing. using p-value method. Okay, that is our example 5. Example 6. Suppose you are running a study poll about the proportion of voter who prefer candidate A. Okay, you randomly sample 147 people, so that's your n. N is 147 people, and find that 82 of them match the condition you are testing. So x is equal to 82. Meaning of that is, if you want to find the proportion from this information, if you want to find the proportion of people, okay, who prefer candidate A, that will be 82 out of 147. 82 out of 147, which is equal to 0.5578. That is the proportion of people who prefer candidate A. Okay, that's our p hat. Suppose that you have the following null and alternative hypothesis. So null and alternative hypotheses are given here. Null hypothesis, p equal to 0.57, and alternative hypothesis, p is not equal to 0.57. So that is, you have the two-tail test there. We are asked to calculate the test statistics rounded to 3 decimal places. So here we don't have to do the entire hypothesis testing process. We just need the test value. So what we know is the formula for the test value, because this is about the proportion, so the test value will be z, and is given by the formula p minus p hat over square root of pq over n. And if we plug in the values here, p is here in this equation, p is 0.57, 0.57 minus p hat, that's the value that we got here, 0.55, 0.5578 divided by square root of p is 0.57, and q will be, if p is 57%, the other one will be 43%, so 0.43 divided by the sample size. In this case, the sample size is 147. So what we get here is z equal to, okay, z equal to, if we simplify this one, we'll get 0.2988. But remember, this is a two-tail test, okay, because this is a two-tail test, we have a not equal to sign. It can be both positive and negative. Okay, it can be both negative or positive. Depending on the type of diagram you are making or the situation you have, you can take the positive value or negative value. If the positive value doesn't work, then definitely it's the negative value. That means you're working on either the left tail or the right tail. Okay, that is your test statistics for example 6. And here we are asked to round to 3 decimal places. So if you round this to 3 decimal places, it will be 0.299 in fact. Okay, 0.299 if we round it to 3 decimal places. Okay, next hypothesis question number 7. Test the claim that the mean GPA of 90 students is significantly different than 2.9 at 20% significance level. So here we are asked to state the null and alternative hypothesis, but here we are talking about different. So different means not equal to, that goes to the alternative hypothesis. So your null hypothesis will be GPA, the mean GPA, mean means mu, is equal to 2.9, null hypothesis, and alternative hypothesis will be H of A is mean is not equal to 2.9. Mean is different from 2.9. And in this case, mean is different from 2.9 is the claim. Okay, is this a one tail or two tail test? Because we have a not equal to there, this is two tail test. Okay, this is two-tail test because we have not equal to in the alternative hypothesis. Now, in order to test this, based on a sample of 35 people, okay, based on a sample of 35 people, that means n equal to 35 people, the sample mean GPA was 2.85. So sample mean GPA was 2.85 with a standard deviation of 0.07. So the standard deviation for this sample, so the sample standard deviation is 0.07. We have to find the p-value to 2 decimal places. Now, in order to find the p-value, first we need the test statistics. So let's calculate the test statistics for part C. So in this one, because the population standard deviation is not given, they have given the sample standard deviation. Okay, the test statistics will be our t-value, where t is equal to x bar minus mean over the sample standard deviation divided by square root of n. This is the formula. So here we plug in the value. So this one, x bar is 2.85 minus the mean is 2.9 divided by the sample standard deviation is 0.07 over the square root of the sample size. Here the sample size is 35. And if we simplify that using calculator, the value of t will be negative 4.2258. So now, in order to find this p-value, we are going to use the t distribution. So let's do it down here. First, we are going to draw the t distribution. Okay, suppose that is my t distribution with the degrees of freedom equal to, here we have 35 as the sample size, so degrees of freedom must be 34. Okay, so this is t distribution is with 34 degrees of freedom. T values along the x-axis. And then because this is a two-tail test, the rejection region is on two tails. So let's show that like this. So that we have half of the p-value on the right tail and half of the p-value on the left tail. And here we got the t-value, which is negative. So which goes here, negative means it will be on this side. So that is negative 4.2258. So now we need to find this p-value first. So in order to find this p-value, we need to find the p-value on the left tail, that which is half of p-value in fact, and then multiply by 2. So we can say this p-value is equal to, in order to find the area under the t distribution, we use TCDF. In this case, the lower boundary on the left is all the way up to negative infinity. So negative E99. Upper boundary is this one, which is negative 4.2258. We don't need mean and standard deviation. Instead, we need the degrees of freedom, which is 34. And if we perform this calculation, we get the area on the left tail. But we want the total area, so we have to multiply this value. After we get this value from calculator, we have to multiply the result by 2. And if we do that in our calculator, make sure you check it, we get 0.0002. Okay, so p-value will be 0.0002. We cannot write up to 2 decimal places here, because if we go to 2 decimal places, it will be 0. In fact, it's not 0, it is 0.0002. So I'm going to write all 4 decimal places there. So for part C, your p-value is equal to 0.0002. Okay, that is the p-value in part C. Now we look at part D. Let's see, what is asked in part D. Okay, here based on above result, do we reject null hypothesis or fail to reject null hypothesis? That is what we need to check. And here we are looking at 20% significance label. Alpha is 0.2, P is 0.0002. So clearly value of P is less than alpha. Since P is less than alpha, we reject null hypothesis. Okay, we reject the null hypothesis. We reject the null hypothesis. So the correct option is reject the null hypothesis. Okay, that is our 7th example. Let's move on to the last example, the 8th example here. Okay, here you wish to test the following claim at alpha equal to 0.05. That's your significance label. Null hypothesis is given, alternative hypothesis is given, and alternative hypothesis is your claim here. Okay, you believe that the population is normally distributed. Okay, population is normally distributed. That's also given to us. But you don't know the standard deviation of the population. So you don't know the population standard deviation. That means here they are trying to tell us that the distribution will be T distribution. You obtain a sample of 19, n equal to 19, with the mean of 79.4. So for this sample, the sample mean is 79.4, and the sample standard deviation is 13.6, because you don't know the population standard deviation. So here what we are asked to do is, in the first part, we are asked to calculate the p-value. So in order to calculate the p-value, the first thing that we do is we find the test statistics. So for part A, our test statistics T is equal to x bar minus mean divided by S over the square root of n. If we plug in the value, our mean is 79.4. 79.4 minus population mean mu is 77.2. 77.2 over the sample standard deviation is 13.6. And we have to divide that by the square root of sample size. Sample size is 19. And if we simplify this using calculator, we should get 0.7051. So that is the T value. Once we get the T value or the test statistics here, what we need to do is we need to find the P value. So to find the P value, because this is the T distribution, we are going to draw that distribution and find that area. So let's first draw the distribution. Okay. Suppose this is my T distribution there, and this is the T distribution with 18 degrees of freedom, because n equal to 19. So this is the T distribution with degrees of freedom equal to 18. And because we have a greater than in the alternative hypothesis, the rejection region is on the right tail. Okay, the rejection region is on the right tail. So we can draw the rejection region on the right tail. And this value is 0.7051. This T value that goes along the x-axis is 0.7051. So now you can easily find the P value. So this P value is equal to TCDF. Okay, we use TCDF, lower boundary 0.7051, upper boundary E99, and then the degrees of freedom is 18. And if we simplify this using calculator, we can easily find our P value. So let's type this in calculator and get that value. So this implies our P value will be equal to 0.2404. So if we go to second vars, you'll see the distribution, and we can use TCDF to get this value in TI-84 calculator. So we got the p-value. So that is the first part. In part A, we are asked to find the p-value. To find the p-value, first we find the test statistics. We draw this distribution, okay, plug in all the information, then use TCDF, we get that. Next one, in part B, we are asked to compare the p-value with significance label. So our p-value is 0.24 and the significance label is 0.05. So you can see that the p is greater than alpha. So we can say p value is greater than alpha. So for part B, p value is greater than alpha. Okay, is greater than alpha. Now, since p is greater than alpha, do you reject or fail to reject the null hypothesis? In fact, we fail to reject the null hypothesis. Okay, we fail to reject the null hypothesis because p is greater than alpha. P is greater than alpha suggests that we fail to reject the null hypothesis. So that means we fail to reject the null. We are not rejecting the null. Instead, we are rejecting the claim up there. Okay, we are rejecting the claim. We are rejecting the claim and we are supporting the null hypothesis. Okay, so that is the meaning of that. We fail to reject this. We reject this one. We reject the claim. That means there is no sufficient evidence to support this claim at 5% significance label. That is the meaning of that. So the conclusion will be there is not sufficient sample evidence to support the claim that the population mean is greater than 77.2. We don't have the evidence to support this claim. So that is the end of this video. I hope you find this helpful. Thank you so much for watching. If you are liking these videos, don't forget to give a like. And if you want, subscribe to the channel as well. Thank you.